Hi, Geometry. I thought I'd take advantage of the second leave. In any case, we are going to find angle measures and polygons, okay? We already know the sum of the interior angles of a triangle is equal 180, and quadrilaterals like a square or a rectangle would be 360. There is a pattern, so we'll be finding that out. So I can find the angle measures and polygons, and I can describe the angles in baseball parks and other real-life situations. All right, so let's grab a pen here. Hopefully this one works. If the measure of two angles of a triangle are 19 and 80, find the measure of the third angle. So, well, remember, they all three have to add up to 180, so I'm going to subtract 19 and 80 from them. You could distribute this negative and subtract both of them. That's fine. But you're going to get 81 degrees. Okay, so it's going to be an acute triangle right there. How about this one? Solve. Well, if you can, divide both sides by the 180. Otherwise, you could distribute to both if you wanted and solve from there, but let's just try to save us some time here. When I divide both sides by 180, I'm going to get x minus 2, because these cancel, is equal to 11. And then I'm going to add 2 to both sides. X is equal to lucky 13. How about this one? Find x. Remember, this is an exterior angle. It would equal the sum of these two angles, but that's not important right now. We also know that these two equal 180. So if you just take 180 minus 54, you're going to get x. So x is 126. But that also means angle 1 plus angle 2 is equal to 126. Recall the sum of the two remote interior angles is equal to the exterior angle. Alright, how about our key concept here? In a polygon, two vertices that are endpoints of the same are called consecutive vertices. For instance, B and C are consecutive vertices because they both contain an endpoint of the same segment. They're just on opposite sides. Okay. Now, a diagonal of a polygon is a segment that joins two non-consecutive vertices. So, for instance, from point B, I have one diagonal here, one there. Okay, so we have two diagonals. Does that work? Yeah, that's better. Here we go. Investigate the sum of the interior angles in the polygons. Okay, so what we're going to do is draw convex polygons with 3 sides, 4 sides, 5 sides, and 6 sides. Apparently I did that for you. And each polygon, draw the diagonals. Well, there are no diagonals here, so there's only one triangle that comes out of it. Now, in a quadrilateral, you can only draw one diagonal. You end up getting 2 triangles out of it. When you have a pentagon, it's a 5-sided figure, you'll have 2 diagonals, 3 triangles. And this looks like some type of hexagon. We have 3 diagonals, 1, 2, 3, 4 triangles as a result. So in each polygon, draw all the diagonals from one vertex. Notice the diagonals divide the polygons into triangles. So basically, the number of sides will cut it in the number of sides. There's a formula: compare the number of sides, number of triangles, stuff like that. So that's going to lead us to this next part. All right. So complete the table. You ready for this? By the triangle sum theorem, the sum of the measures of the interior angles of a triangle is 180. Okay. So what they're saying is all 3 angles here equal 180. All 3 here equal 180. All 3 here equal 180, etc. So you're going to see a pattern. So for instance, triangle has 3 sides, has one triangle. The sum of the interior angles would be 1 times 180 minus 1 times 180 equals 180. A quadrilateral will have 4 sides. Okay, and if you recall, quadrilateral ends up with 2 triangles. So you're going to take 2 times 180 is equal to 360. Pentagon. 5-sided figure. 3 triangles. 3 times 180 minus 360. Are you seeing a pattern? Hexagon. 6 sides. 4 triangles. 4 times 180 minus, or equals 720. Oh, wait, this is 540. How come you didn't say anything? 540. What am I doing? Okay, what do you notice? Well, whatever the number of sides is, take 2 away, multiply by 180. So n minus 2 times 180 is equal to the sum of the interior angles. These are all little degree symbols here. All right. Polygon interior angles theorem, and here it is. The sum of your sum of the interior angles of a convex n-gon is n minus 2 times 180. Okay, so add up all these angles. It's going to equal 540. It's a pentagon. So far, so good. Corollary for the interior angles of a quadrilateral. The sum of the measures of an interior angles of a quadrilateral is 360. So when any fourth-sided figure, whether it's a rectangle, a square, trapezoid, diamond, rhombus, whatever, always equals 360. Okay, so I know you don't need a corollary for that. You can always remember the formula of the table, but it comes up a lot. All right, so let's put this to action here. Find the sum of the measures of the interior angles of a convex decagon. Okay, so a decagon, n is equal to 10. So you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our formula, n minus 2 times 180 is equal to 10 minus 2 times 180. 8 times 180 is equal to 1440. Wow, crazy numbers today. So 1,440 degrees if you add up all those angles. The sum of the measure of the interior angles of a convex polygon is 2,340. How many sides are there? Well, now let's work backwards. N minus 2 times 180, now you're going to see why I had that problem in the warm-up, is equal to 2340. Instead of distributing, I'm going to divide both sides by 180. So n minus 2 is equal to 13. Add 2 to both sides, n equals a 15. So we have a 15-gon. I don't think there's a name for that, so usually when there's not a name, you just put gon after the number. All right, find the value of x in the diagram shown, then find the 2 missing angle measures. Well, all those angles, let's see here, we have a 4-sided figure, n is equal to 4. According to our corollary, the sum is going to equal to sum of the interior angles, 360. So let me add them up. I have 10x plus 7 plus 88 plus 5x plus 3 plus 127 is equal to 360. All right, let's add up all the x's. Just those two, 15x. Add up your numbers. 225. Double check for me, please. I'm going to subtract 225 from both sides. And then divide by 15. X equals 9. Okay, so then find your 2 missing angle measures. Well, if we plug 9 in here, I have 10 times 9 plus 7. 10 times 9 is 90 plus 7. We get 97 degrees. Then here, 5 times 9 plus 3. 5 times 9 is 45. Plus 3 is 48. So far, so good? It looks nice in color, doesn't it? All right. Exterior angles. Now, regardless of the size of the polygon, guess what it's always equal to? 360. So you can't get this one wrong. Add up all your angles. Notice that the formula says the measure of angle n, so it doesn't matter how many you have. 360. These are exterior angles. Notice they don't do double exterior angles, like do this one with it. Okay, so they don't do that. And now we will do one of those examples. All right, so I have exterior angles drawn. We're going to add them all up, and what do we set them equal to? 360. Here we go. 121 plus x plus 82 plus 108 equals 360. X is equal to 49. Yeah, I had the answer just to the side. That's why I knew it so fast. Okay, here we go. A stop sign is shaped like a regular octagon. Regular means all sides are the same. Find the measure of each interior and each exterior. Okay, so let's do the interior first. So n is equal to 8. So n minus 2 times 180 is 8 minus 2 times 180 is equal to 1080, 1080. So that's the sum of them. That's all of them. But I want to find each one. Well, how many sides do we have? 1, 2, 3, 4, 5, 6, 7, 8. I should have known from right there. But if you divide each one by 8, you'll have each angle. So you get 135 degrees for each interior angle. Okay, I don't know why I abbreviated or made that apostrophe S. Now let's look at the exterior. Remember, the sum of the exterior is equal to 360. Divide that by how many we have. We have 8 of them. You're going to get 45 degrees each. And that actually makes sense. Think about it. If I were to extend this angle right here is 135. This angle is 45. What will those add up to equal? Straight line, 180. All right, a little bit of a summary. I kind of like this. Angle sum theorem tells you about how many sides are in each shape, interior angle, exterior angle, etc. How to find each one, and good stuff right there. Now, this is actually a table that I want you to fill out on your own. You can go ahead and try to do this on your own, like pause me right now and see if you can figure it out, but it helps you with all the formulas. Okay, number of sides. Triangle has 3. The sum of the interior is 180. Each interior angle, take 180 divided by 3. You're going to get 60 degrees each if it's regular, okay? The sum of the exterior angles is 360. And each one, take 360 divided by 120 if it's regular. Actually, I was going to highlight that, but here I've got pink. That pops out. Okay. So you're going to take 360 divided by 3, you get 120. Now let's do a quadrilateral. 4 sides. They add up to 360. If you take 360 divided by 4, you get 90. This will always be 360, actually across the board, right? And if you take 360 divided by 4, you're going to get 90. A pentagon. 5 sides. Remember, you have n minus 2 times 180 for all of these formulas going across. Maybe write it down right here on the side. And then if you wanted each one, take n minus 2 times 180, divide by n. This one will always be 360, and then take 360, divide by n. N would be the number of sides. So there's your formula for each one. All right, so let me fill these out. 540. Some students memorize these. I really don't recommend it. I'd rather have you know the formulas and understand how they work. And keep in mind, these two should always add up to equal 180, right? Because they form a straight line. Heptagon, 7 sides. I've also seen this called septagon. Not too often, though. It doesn't go in there nicely, does it? An octagon. We just did this problem with the stop sign. And then n-gon. Here are your formulas again. (180). there you go. So here is our homework, and there's our Common Core standard. Have a nice evening, and please keep warm. Hopefully I'll see you on Monday.